Hi guys, back again with another edition of crappy internet reception. This is my kitchen behind us here because I tried to go outside, but things were not looking good out there in terms of internet either, and my battery was going dead. So back to my shared screen, I'm going to go over objective numero tres for you. All right. And so we're going to identify and explain the problems with quasi-experimental design. Let's take a look. What are they is the question. Why in hell won't my thing advance? Page down. Okay. Problems with quasi-experimental design. Number one, it's like, duh, this is the biggest problem, right? Because you don't have random assignment, you have the problem of the experimental group being different from the control group in a variety of ways. So let's take, for example, the drug treatment group. So we have a drug treatment clinic that is getting the treatment, and then we look at people who are not getting the treatment. The problem is, if you have a bunch of drug addicts and some are getting treatment and some are not, they're probably pretty different. So people who are getting treatment, for example, might have more resources, they might have more family support, they might be more motivated to quit. And so if we find out that the treatment group actually does better than the no treatment group, it may not be because of that treatment at all. It could be because of pre-existing differences. So that problem we call selection. And it's a problem of the groups being different to begin with. Secondly, we have a problem called history. History is when a confounding event occurs between the pre and post test. So for the rest of these, I believe the rest of these are all going to be problems with pre-test, post-test. So with history, we have the problem of something occurring between the pre-test and post-test, which is a confounding event or an extraneous variable. So for example, let's take when we have a pre-test for the exit exam, and then we have the LU education, and then we have a post-test to see how much people learned while they were in education at LU. The problem of history is the history of other stuff that happened in between the pre-test and post-test. So for example, let's say students worked off campus, and in fact, they learned a lot from their work off campus. Maybe they were doing work in the field of psychology. And so then we have this problem of, well, they get better from pre-test to post-test, but can we be sure it was because of their LU education? Another thing that is a problem, and especially with longer time courses in studies, is called maturation. And that's just that people mature between the pre-test and the post-test. So let's say we took people who, again, the exit exam, and then we have LU education, then we have another exit exam, a pre-test, post-test design. What we have is a problem of it's a 4 years in between there, 4 or 5, even 6 years sometimes. And so people are going to mature during that time, and they may get smarter just because they mature, not because the LU education was effective. So that's a problem. The testing effect is when taking the pre-test affects the participant's behavior. So what might happen is so LU students come in fresh and they take that exit exam and ask them all about psychology and blah, 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 blah. And they don't know anything because they haven't done anything yet. But then what happens is they're alerted to what's on that exam. So during their 4 years of education, then they pay particular attention to what was on that exam, so they do better on the post-test. But it was actually a testing effect because it was influenced by the fact that they took the pre-test in the first place, because now they knew kind of what to look for, sort of thing. So we can't be sure that, again, the LU education was effective without that pre-test, to alert them to what they're supposed to be looking for. One more problem with the quasi-experimental design is called regression to the mean. Regression to the mean is just something that tends to happen to extreme scores. So for those of you who've had statistics, you know that if you look at a normal distribution, you have the extreme scores out in the end. If you're testing somebody with an extreme score and you test them again, they tend to move in toward the mean. So the very high scores out here will tend to move a little bit lower. The very low scores out here will tend to move a little bit higher. So people who score extremely high or low on the pretest will tend to score closer to the mean. That'll move that way just by chance. So if you choose kids, for example, for your experiment, let's say we're doing an experiment on an intervention for elementary school kids, Now, I've taken some charter school performance in St. Louis here, and you can see that there's certain schools that are doing very, very poorly. Here you can see the St. Louis Public School average, the Missouri Public School average, and this school, Imagine College Prep, woo, they ain't doing too well at all. Hope none of y'all went there, because that school sucks. Anyway, this is their math proficiency. Let's say we have some kind of summer math program and we test those students in that program. We do a pre-test, post-test. So we test them now, their scores suck, then we do the summer program, and then we test them again. There's going to tend to be a regression to the mean. So their scores are going to tend to get better, not because the program was really good, but because they were such an outlier in the first place, they're going to tend to come back to the mean. So that is that's a problem. We don't know that our program was effective if we test, you know, very high or very low people and we test them twice. Okay, so you go ahead and give this a try. Try criticizing this study, reporting the results of an after-school program. You can see that this is a pre-test, post-test design here. And what they did, these are two sets of findings on two different dependent variables here. Students are reporting better school attendance after this after-school program. They started out at 57% attendance, now at the post-test are at 89%. On the pre-test here, the academic self-improvement, students are reporting better grades here. And so here we have pre-test versus post-test are doing better. So can we be sure that the after-school program worked is the question. So we want to look at a history effect. We want to look at testing. We want to look at regression to the mean. And we want to look at maturation. Now, maturation is unlikely to be a big effect because all it is the summer, so they haven't had too much time to grow and mature, you know, for this after-school program or you know, semester or whatever. But if the program had taken place over a long period of time, perhaps so, maturation could have an effect. We don't know how long there is between pre-test and post-test right here. Is there a history effect? Yes, absolutely, because they, you know, during the time they were in this after-school program, other things might have also happened. They might have been getting special instruction at home, or things could have changed elsewhere in the community, and those might be the cause of the increased attendance and increased better grades. If they started out with a particularly low group of students, regression to the mean might have taken place. If they took the worst performers to begin with, they will tend to get better just by regression to the mean. So hopefully you understand that. Testing, you know, I mean, if they were aware of what was going on in the pre-test, and then, you know, they tended to get better because they knew they should get better. That's a demand characteristic. We talked about that in the last chapter. Okay, we're going to go on to objective 4 in the next video. You guys stay with me.